Hello viewers, in today's session we are going to discuss another important and conceptual problem from functional equations. So here in this session we are going to discuss this problem in which we are given a functional equation, that is f of xy is equal to 2 times f of x minus f of x over y for all x and y belonging to the set of positive real numbers, and moreover here x and y are not equal to 0. And here two conditions are also given, that is f prime of 1 is equal to 1 and f of 1 is equal to 0. So we have to find out the second derivative of the function f at this point, that is square root of pi. And in addition to this, it is important to note that here we are taking this point as x is equal to square root of pi, right? And here we have to consider the positive square root, because this equation is valid for all values of x and y belonging to the set of positive real numbers. So when we are considering square root of pi, it implies that we have to take the positive square root. So now to get the value of f double prime of square root of pi, our aim is to find out the function f of x, right? So once we find out the form of the function f of x, we can differentiate it to get f prime of x, and then we can find out the second derivative, and we can substitute x is equal to square root of pi to get the value of this expression, right? So here what we will do, will make use of the concept of partial differentiation to solve this problem. So now let us rewrite this equation as 2 times f of x, and that is equal to f of xy plus f of x over y. So taking this term, that is minus f of x over y, to the left hand side, we can now have this equation, right? So now let us differentiate both sides partially with respect to x. So what we will get, we have 2, then we have del by del x of f of x, and here we have del by del x of f of xy, and here we have the derivative, that is f of x over y. Now the derivative of f of x with respect to x is given by f prime of x, and here we have the derivative of f of xy with respect to x may be written as f prime of xy, and then by chain rule we have to differentiate this function, that is xy, and here also the derivative of f of x over y is f prime of x over y, and then by chain rule we have to differentiate x over y with respect to x. So now we have 2 f prime of x, and here we have f prime of xy. Now we have to find out the partial derivative of xy with respect to x, so we can take y as a constant. So we have y and the derivative of x with respect to x, and similarly here we have f prime of x over y, and here we can take y as a constant, so we have 1 over y and del by del x of x. So we can now write 2 times f prime of x, here we have f prime xy, and here we have y simply because the derivative of x with respect to x is 1, and here we have f prime of x over y, and the derivative of x with respect to x is 1, so we can now take this 1 over y in front of f prime of x over y. So now we have this equation. So let us call this equation as equation number. So in the first step, we have taken the partial derivative of both sides of this equation with respect to x. Now let us differentiate this equation partially with respect to y. So we have 2, and here we have del by del y of f of x. Then here we have del by del y of f of x y. And here we have the derivative, that is fx over y. Now see here, f of x is a function of x only, and we have to take the partial derivative of f of x with respect to y. So here f of x may be taken as a constant, so the derivative is 0. So here we have 2 times 0, and here we have f prime of xy, and then by chain rule we have the derivative of xy, and here also we have f prime of x over y, and by chain rule the derivative of x over y. So here we have 0, and here we have f prime of xy, the derivative of xy with respect to y. Now we have to keep x as a constant, so we can now write simply x, and here we have del by del y of y, and here we have f prime of x over y, and here we can take x outside the derivative operator, and we have del by del y of 1 over y, that is y raised to minus 1. So this is 0, and here this derivative is 1. So we have simply x f prime of xy, and here we have this term as x, and f prime of x over y. The derivative of y raised to minus 1 is minus 1 over y square. So now we have 0, x f prime of xy, and we can take minus 1 over y square over here. So we have minus x over y square and f prime of x over y. So this is equation number 2. So now let us solve these two equations, and here we'll solve these two equations by elimination method. So let us multiply this equation with x over y, so that here we get x over y square, and here also we have x over y square. So here our purpose is to equate the coefficients of f prime of x over y, right? And after multiplying equation 1 with x over y, we'll add this equation and the resulting equation which we get after multiplication. So multiplying equation 1 with x over y, so here we have 2x over y, and here we have f prime of x, and then here we have y. So x, this y and this y get cancelled, so we have simply x and f prime of xy, right? And here we have plus x over y square and f prime of x over y. So let us call this equation as equation number 3. Now we can add these two equations. So here we have 2x over y, f prime of x, and here see these two terms get cancelled, and we have here 2x f prime of xy, because x f prime of xy, these two terms are like terms, so we can simply add these two terms. So adding equation 2 and 3, we have now this equation. So let us call this equation as equation number 4. So now multiplying, cross multiplying here, by y, so we have 2x f prime of x, and here we have 2xy f prime of xy. Now we can rearrange the equation. So we have minus 2xy f prime of xy is equal to 0. So taking this term to the left hand side. Now taking or dividing both sides by 2, we have simply x f prime of x minus here we have xy, and f prime of xy is equal to 0. Now we can take x common, so we have f prime of x minus y f prime of xy, and this is equal to 0. Now here we have the product of two terms. The first one is x and the second one is f prime of x minus y f prime of xy. Now since we have here x not equal to 0 and y is also not equal to 0, so this x cannot be equal to 0, so this factor must be equal to 0. So we have f prime of x minus y f prime of xy is equal to 0. So now we can write f prime of x is equal to y f prime of xy. So now we have this important equation, that is equation number 5. So now let us replace y by 1 over x in this equation, that is equation number 5. So we have f prime, and here we have x, and for y we can now write 1 over x, and here we have f prime x and 1 over x, right? Now here this x and this x get cancelled, so we have f prime of x is equal to 1 over x and f prime of 1. And here we are given that f prime of 1 is equal to 1, so we can now write 1 over x times 1, that is 1 over x. So we have now f prime of x is equal to 1 over x. So f prime of x can be written as d by dx of f of x, and this is equal to 1 over x. So this is a differential equation, and we have to solve this differential equation by integrating both sides. So let us integrate both sides with respect to x. So here we have dx, and here we have 1 over x dx, and c is the constant of integration. So the integral of the derivative of f of x is simply f of x, and here the derivative, the integral of 1 over x dx is a log of x, and c is the constant of integration. So now we have the form of the function that is f of x, which is equal to the natural log of x plus c, where c is the constant of integration. And we can find out this constant of integration by using this condition, that is f of 1 is equal to 0. So when x is equal to 1, then f of 1 is equal to 0. So in this equation, let us take x is equal to 1. So we have f of 1, here log of 1 plus c. Now f of 1 is 0 and log of 1 is also 0, and here we have c. So this implies that the constant of integration, that is c, is equal to 0. So now taking c is equal to 0 over here, we have f of x is equal to log of x plus 0. So we have f of x is equal to log of x, right? So this is the form of the function f of x, and here if we differentiate f of x, we'll get f prime of x is equal to 1 over x, because the derivative of log of x is equal to 1 over x. and the second derivative is obtained by differentiating 1 over x. So we have d by dx of 1 over x. So this is minus 1 over x square, right? So we have obtained the second derivative of f, that is f double prime of x is equal to minus 1 over x square. So now we have to find the value of f double prime of square root of pi. So let us substitute x is equal to square root of pi. So here we have f double prime square root of pi, that is equal to minus 1 over root pi square, that is equal to minus 1 over pi, right? So the square of square root of pi is pi. So where's the value of this expression is equal to minus 1 over pi.